Alright, so I got 4 footballs, 5 basketballs, 3 volleyballs. They're all going to be arranged along a line. I want to know how many ways there are to arrange them if the balls of the same type, like all the footballs, are indistinguishable. What does the word indistinguishable mean?
They look exactly the same.
Yeah, you can't tell them apart. They look alike. So therefore, yes, you do like you did at the top. That means alike. So yes, okay. Where's Casey getting 12 factorial? Yep, add them all up. There's 12 total. Yep. Exactly. 4 factorial, 5 factorial, and 3 factorial. So each type of ball looks exactly the same. Maybe they're brand new balls from the same company. There's nothing on them to make them. Maybe this is a display in a sporting goods store. Who knows? Okay, I'm looking to see if I have this one worked. I do. 27,720. Oh. That's only a few different choices. Alright, that was method number 3. You only do that if you have things that look alike. If they don't look alike, you don't worry about it. Oops, and this is where I evidently didn't get it deleted. Oh, seriously, it just cannot handle speed. Just cannot handle speed. Okay. Yes, this is method number 4. I didn't get it.
Method number 4.
Okay, this is what I call the special situations deal. If they tell you certain objects have to be in a certain position in the pattern, or they tell you you can reuse an object, like if you're doing letters, patterns with letters, if you can reuse letters, it changes how this works. And in fact, there isn't an official formula or rule for doing it. If they give you something special, you have to just do it by drawing out the little blanks and asking yourself how many ways are there to go in each blank. There's no easier, better way.
That we've come up with.
Yes. Okay, so in this case, once again, suppose I'm going to fill the front row with 7 people, 1, 2, 3, 4, 5, 6, 7, but I have determined...
Story has to sit in the front row in the middle.
Story has to sit in the front row in the middle. I am determining that I have to have... I better do this the other way, because it'd be the juniors I'd want to spread out. No. I'm spreading out the troublemakers. Okay, I want juniors on the end. And I did 7, so that blows up my pattern. Oh, we'll do this. We're going to put our senior dead center here. And I want sophomores on either side. I do not care who's in the other spot. I just don't. Okay. But I'm giving you specific people certain types of people have to be in certain places. Whenever you're going to do this, fill in those spots first. So, when I go to put a junior here, how many juniors do I have to choose from?
Well, there's 14 of us currently. 1, 2, 3, 4, 5, 6, 7.
There are 7 juniors in this room. Oh, 8 with Caleb, yes, 8. So we would have 8 juniors. Now, go do the other junior. So then there would only be 7 left down here. Okay, there's only 1 senior, so...
There's 5 sophomores, so it would be 5 and 4.
Because that would be, yeah. So if there are 5 sophomores to go here, there are 4 left to go there. Now, what goes in the other 2 blanks? How many total people are left that we haven't already seated?
6 and 3.
We just put 5 people in their spot. There's 14 of you total. So there would be 9 people left and 8 people left. And then you would multiply them all together. It's a big number, but it's not going to be as bad as some of the numbers we've just done. But unfortunately, I don't, since we did this specific to your class, I do not know this number. 92,160, wow. That's still a lot of patterns we can make out, you guys.
I think I got a different number than Casey.
Because 8 juniors and 7, that was one thing. The sophomores were one thing. There were 9 people left, then there were 8 people left total.
No, I put the 8 at the end for the juniors.
You seated 5 people, so when you, this could be anybody that's left. There were 9 of you. There's 14 in the room.
It's 80,000.
Oh, yeah, well, I don't get it.
80,640? Okay.
I don't get it either.
Because, no, that's what you're supposed to get.
I seated, there were 8 juniors, and then there were 7 left. That's where the juniors went. Okay, there's only one senior, so there's only one choice for that seat. The sophomores, there are 5 of them, so then there were only 4 left. Okay, now, folks, if I'm explaining this, you better be listening.
Oh, I already understand.
'Cause that's, so, therefore, how many, anybody can sit in these 2 seats. You have put 5 people in their seats, so how many people are left?
Oh, the other one.
There's 9 people left that you can choose from yet. And then if you sit, there's 9 people left here, then there's only 8 left there. And so you can end up with the numbers repeated. Where you're putting things in specific locations like that, numbers
So
can
is
get
there a
repeated.
formula for this one?
No, not literally. The only way you can do these is to draw out the blanks and ask yourself how many can go in each spot. It's the only way.
Yeah, that sounds like a way.
Okay, let me give you an example here. License plates. At least Kansas license plates are 3 letters, 3 numbers.
Yeah.
So we know when we do Kansas license plates, we have to have letter, 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 number, number, number. Okay. Suppose, just to prove my point here, suppose the letters cannot be repeated, but the numbers can. Okay, so how many letters are there?
26.
And this falls into this category because I'm allowing you to repeat and I'm giving you specific locations on things. There are 26 letters in the alphabet. So how many choices would there be for the second blank? Because there'd only be 25 of them left, then 24 of them left. Okay, numbers. How many single-digit numbers are there? What about 0? 10. There are 10 single-digit numbers. Okay, these can repeat.
So there's 10 all the way across.
So it's 10 all the way across, because they can be used over. You can have a license plate with 111 in it. Okay. And so then if you multiply all those together, you'll find out there would be 15,600,000 license plates with that particular restriction. In reality, I actually think you could probably, it's probably 26, 26, 26. I think you can repeat your letters too.
Can I go look at the cars?
So,
How much is it if you're just gonna go look at it?
I don't have it written down, I don't know what it is, it's 26 million. Okay, so why then do you see other states, say California, New York, that have, they may have, where they have like 3 letters and 5-digit numbers. They got way more population, so they gotta have way more tags.
Way more than 15 million people.
So,
There's no way that California kill 3 cars, I mean, someone like me tag, I guess.
yeah, you wouldn't have to have a new tag every time you get a new car, but yeah, that, why, you guys are probably too young to remember it. It used to be Kansas, the top half of Kansas, our area code for our telephones, we were all 913, and the bottom half of Kansas was 316. Then, probably in the 90s somewhere, they split us off. They gave 913 to Kansas City and like Atchison, just a little bit area over there, and we all became 785. Why did they have to do that?
Population.
What's a population? Our
Oh,
population.
cell phone?
Cell phones, fax machines, all the electronic devices that now needed their own separate number, they didn't begin to have enough phone numbers, so they had to start splitting up areas, making more area codes, so they had more patterns.
That's what I'm at, population of machines.
Yeah.
That's what it
You
is.
did it backwards, by the way.
Machines are taking over the world.
What?
The numbers are on the left. Numbers on the left, letters on the right.
No, they're not.
So what?
You just overtyped that thing.
I went to argue with him, he just looked it up.
Cause I'll swear I'm A-L-N
No,
something something.
the letters are on the right.
Letters?
When did we switch?
Yeah, I thought
What's
they
the
did.
new license plate?
Or the
The
new
letters are on the left.
I swear, cause I
There's
used,
new license plates coming out.
or maybe, okay, the new,
What?
Sure, I think the blue ones are.
alright. So seriously, they've switched. Well, that's interesting, alright.
Yeah, I went to argue with you.
Okay.
You missed the word.
I missed the word, that's okay. Alrighty. That's permutations, patterns. The hard part for you on doing permutations and patterns is you gotta decide, do I have repeated objects? I don't have repeated objects. Am I using all the objects? Am I only using a small group of the objects? You gotta look at those 4 rules and decide which one am I doing. Okay, I didn't explain this earlier. Your blue handout that I gave you, that handout is good for days. Do not work your problems on the blue handout.
Right?
Because you're gonna need that for the next 3 days.
Yeah, do it on
You
handout.
can't be turning the handout into me, so do not work on the blue handout. You have permutation some of your problems are on there. Anytime your assignment sheet says handout, it's that.
Hey, your thing's over, man.
My thing's over.
Well,
No, it's not. Really? Seriously? That went that fast already? Oh.
Are we done?
Heck no. Okay, brief, turn back on. Okay, the good news with combinations, there's only one way to do it. There are not multiple methods. One way to do combinations. The problem is, excuse me, this is really important because this is where people have trouble. How do I know when I'm doing a permutation, or how do I know when I'm doing a combination?
One is a column and the other is
Okay,
a row.
combinations, if you'll notice this definitions, are ways to select groups of objects. Okay, notice, you're selecting groups, that's a key factor, and you don't care what order they're in. You're not making patterns out of them. You just want to know how many different groups can I pick. You are not concerned about whether they're in different patterns. Only you want groups. A classic example, 12 people on the basketball team. How many teams of 5 can you put on the floor? How many different groups of 5 people can you put out there on the floor? That's a combination. Because you don't care, you're not necessarily caring what pattern they're in, just how many groups can I pick. So combinations you're going to think groups, and you don't care about the patterns at all. You just want to know how many groups there are. And, okay. There's somewhere else here. The one and only way to do combinations, the good news, remember our NPR we just did?
NCR.
There's NCR for combinations.
Is there even a difference between
Is
them?
this on?
No, probably not. It's probably not on your journal because there's only one way to do it.
Actually, there's a constant for how NPR and NCR.
I'm getting to that in a second. That's coming here momentarily. Once again, N is still the total number. R is the number to be used. Same thing every time. Okay, so suppose I decided I am going to select from the 14 people in this class, I need a committee of 4 people to serve on my I Love Math committee.
You're not going to find very many people.
It's not an option for who wants to serve. I want to know how many different groups of 4 can I choose from this room.
1001.
How'd you do it?
Instead of the whatever, I did the NCR.
Okay, because she went menu, probability, combinations.
And then I did 14
And she did, so she got NCR and she did 14,4. Is she right? Yeah. There are 14 people, she's picking 4 of them, and you got what? 1,001. No, don't freeze on me.
Hey, you're over the time.
Ah!